Okay, the quick synopsis of what we did in the MDE, and I do recommend doing the MDE. Benefit considerably. However, if you already know the stuff, that's fine. Okay, so we want to find a linear function. If we know that f of 2 is -4 and the slope is 3/8. Now, what does f of 2 equal -4 mean? Well, normally I'd give you time and I'd try to drag it out of you and see what you know, but it means that x is 2. If x is 2, y is -4. Because we graph y equals f of x. Y equals f of x, so f is 2 is the x, and the f of 2 is the y. Now, that's a fundamental thing that everybody should ideally have understood in the first week, okay? In pre-calculus class, a lot of times you get to this point, people still don't understand that. I mean, a significant number of people in a given class. And a significant number of people who are going to pass the course, maybe with a C or a D, and maybe hopefully a little higher, but it's something you really have to understand. So make sure you lock that in. Okay, so what people will do when they see this is they start casting around for formula. I don't recommend that you go casting around for a lot of formulas. Use a bunch of formulas. Okay, you know, a bunch of formulas. But to avoid having to know an overwhelming number of formulas, you need to understand the picture. So what's a picture of f of 2 equals -4? Well, it's that point on the graph. X is 2, y is -4, so there's a point 2, -4. It's on the graph. What else do we know about a linear function? I've written down here f of -2 equals -4 means y equals -4 when x equals 2, because we're graphing y equals f of x. Okay, that's your reason. You want to digest that. You want to really understand that statement. In any case, it says it's a linear function. It's linear, so we know it's y equals mx plus b. Or if you want, y equals ax plus by equals c. Could be any, but y equals mx plus b is a convenient form since you're given the slope, and the slope is m. Okay. So what do we know? We know the slope of the point. Okay, well, the point 2, -4 means that we can plug in -4 for y and 2 for x, giving us this. And we have a true statement. And we know that m is 3/8. Now we could have done that before we wrote this, but I did it after. Either way, you can plug in 3/8 for m, and look here, we got an equation for b. Well, if we know m and b, then we have the equation of our function. Well, there it is. We just solve this equation for b, we get b equals -19/4. I'm not going to go through detail of solving a linear equation, something you should have mastered long before you took this course, but by now you should totally have that mastered. And if you don't, email me and say, well, I'm a little insecure in this. I've got a drill. Okay. Little either refresh you or show you the types of problems you don't yet know how to solve. Okay. That's an algebra 1 task, but we have to have that down. We can't spend any more time expressing how to solve linear equations with only today and Thursday. Okay, so we solved the linear equation for b. There it is. There are the steps. Let's skip a couple of steps. You should do it yourself and then compare what you get with what I get. But we get b equals -19/4. So y equals 3/8 x minus 19/4. There we go. Okay. Now there's another way we could have done this. And it illustrates what we do if we have 2 points. The slope is 3/8. What does that mean? It means between any 2 points in the graph. Well, it means for any point on the graph, we can run 8 units and rise 3 units, and we get another one. Again, a concept, an idea, a picture that you should lock in. So. Find it here, we got this point on the graph, the 2 -4 point. If we run 8 units and rise 3, then we've got a slope of 3/8, right? So we go run 8 and rise 3, it gets us to the point 10 -1. You can work out the details of that to get this point. It's very easy to do that. Now we've got 2 points in the graph. If we've done that correctly, we can proceed to use our reflex, which is if we have 2 points on the graph, we can do a fundamental triangle. Something else I introduced very early and we used repeatedly. Okay. So we want to, I advocate that you have that picture. Okay, so here's the fundamental triangle. The run is 10 - 2 = 8. 10 -2, x goes from 3 to 10, the run is 10 - 2 to go. And y goes from -4 to -1. Well, -1 minus -4 is 3. And common sense, the rise is 3 and of course. We do that when we constructed the triangle, but if you were given just 2 points, if you're just given this point and this point without being told that the slope is 3/8, it's not a more triangle we give it to you. And I've given people a very specific way to label this, which is the way this is labeled, with a box around the 3/8 and so forth. And almost nobody's doing that. Okay, which means that you need to be a little more attentive to the details of what we're telling you to do, okay? Or what we're advising you, okay? If you don't know how to do that, I introduced that very clearly, very firmly. People did it in class and never did it well. And I'm not criticizing you for that, that's human nature, okay? And I like the fact that you're human. But take a lesson from that in how you focus and attend to things that we do. Now it's a little late to go back and have done that, but in the future, you have to attend to the details. And one of the big problems people have, and there's several big problems you can have, okay? But one of the big ones that I see always in a pre-calculus class is they all get to attend to the details. Probably because in high school you didn't really have to. Okay. That's not a criticism of your teachers. They're tasked with the class of 30 people, 20 of whom will never learn what they're teaching, but they still have to pass. So what do you do? Okay, well. So the alternative, even for this thing, would be to take those 2 points, 2, 4, and 10 -2, and find the equation. Now there's a formula, y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. You want to memorize that formula and use it, okay, but memorizing the formula can be pretty insecure. And if you memorize the formula and use it without the picture, you're not understanding as well as you could. You might get the right answer, but you're not understanding. Okay, so you want to understand it, which is where this picture comes in. So anyhow, if you're just given these 2 points, you would use a fundamental triangle or the equivalent, rise over run, whatever. Okay, and you would find that the slope is 3/8. Right there, I've calculated. Then we could use the point 10 -1. And I chose to use 10 -1 because I already did this with the point 2 -4. I'm going to repeat that. Go to the point 10 -1. Use the point 10 -1 and we write, well, we just do the same thing we did here. There are our steps. There's our solution for B. And it's the same solution we got here, but these are a completely different point. Okay. There's an important lesson in that. Okay. You're not going to have time to copy everything on the board, but it's there. Okay. Another question that came up. In the MPE. Again, goes to the heart of. You got V of t equals 80 times 1 minus e to the negative 0.2 t. This is a very, very bad model of person in free fall. Okay. That's supposed to be in feet per second, and in free fall, you can get up to close to 200 feet per second, and this is only going to get up to 80 feet per second. It's easily either a person with a big suit on to slow it down, or that would be about right for a falling chipmunk. They have more surface area per unit of weight than people do. So they catch more wind per unit of weight. And they don't speed up as fast. If you go up with a chipmunk from a mile high, that might live. Probably would. Okay. Probably be a little flick up for that. They can handle that impact just because of proportionalities and stuff. Well, that's totally off the subject, but okay, here's your view to. And you recognize you got an exponential. Okay, well, then what's the velocity after 2 seconds? Okay, think about that just for 10 seconds. What's the velocity? How would you find the velocity after 2 seconds? So, how many of you think you know? It should be pretty instant. If you know that t is time and d is velocity, and you've got 2 seconds, you got to put it in for the time, right? And if you put 2 in for the time here, you have to put 2 in for the time here. So you just say v of 2 is this, and you punch your calculator. You get 25. I did an estimate here, but based on the graph, and it actually came up closer than it probably usually would. So I say approximately equal to 24, it's more like 25. Okay. Okay, well, that's an easy question. Okay. Now this is a 2-part question. What's the velocity after 2 seconds? And then when is the velocity equal to 70? Stated one's velocity 70 feet per second. That's the harder question. It's harder to interpret. And you have to solve an exponential equation. It's a little more involved than some of this. Okay. I mean, if you just keep your wits about you and do your algebra right, you're going to get it. You know, use a natural log thing. Okay. There's nothing particularly mysterious about it. The big jump is knowing that, well, when's the velocity 70? Well, v of t is velocity, isn't it? So v of t is this, and v of t is velocity. So we substitute, so we replace v of t by 70. And we solve this equation for t. Now we'll talk a little bit more about solving this equation, but there's some curveballs in it. So here's the equation. If we substitute, if we declare that v is 70, then we're going to have 70 equals this right-hand side. Okay. And now we got to solve for t. What do we do first? Well, 80 is multiplied by this quantity, so I chose to divide both sides by 80. So dividing this side by 80, the multiplication by 80, divided by 80, divided by 80 is 1, and so forth. So we end up with just 1 minus e to the negative 0.02 t, 0.2 t. Then we get 70 over 80. Okay, we're trying to get t. We still got a 1 on this side that we can easily get rid of by subtracting 1 from both sides. So we get negative e to the negative 0.2 t equals 70 over 80 minus 1. Now 70 over 80 is just 7/8. 7/8 minus 1 is 7/8 minus 8/8, which is negative 1/8. And that should be totally obvious. You really have to be able to do fractions. Okay. If you don't review it, learn as much as you can, whatever it takes. So we get this equal to -1/8. Right? We need the T over on this side. And then later I move it back over to the other side, but okay. We get this equation, and then, of course, we have negatives on both sides, so I multiply by -1. And I get e to the -14 equals 1/8. And then I convert this to logarithmic form. I get log base e of 1/8 equals -0.2t. Now, if you don't know how to convert logarithmic to exponential or exponential logarithmic form, and vice versa, but well, I know it's vice versa. You really need to. I'm not going to do it now. Okay, we've done that very explicitly. What tells you you have assignments on it, and hopefully used it in the assignments in such a way that you maybe don't remember it right now, but with a quick glance, you will. That's where you should be right now. And so when you get into the test with the review, you've got that in the center. Because I ain't getting your formula sheet with all that stuff on it. Okay. Okay, so anyhow. This equation converts in a very straightforward manner to this. And log base e of 1/8 is a natural log of 1/8. To solve for t, we divide this by 0.2. And that's what I've done here. The only difference between the natural log of 1/8 and log base e of 1/8 is the way it's written. And you would want to use a natural log here because you don't have a natural log, not really calculate. Okay. So there it is. And then you punch this into the calculator. Okay. So there's a lesson on that. Now, I pose two questions. Two equations to graph, two functions to graph. Okay. And y equals x squared minus 12x plus 30. Your immediate reaction, whenever you see a quadratic, is use whatever the quadratic formula tells you. Okay. Now, what does a quadratic formula tell you? Well, it tells you the solutions to the equation you get if you set this equal to 0. Well, if you don't understand, that's what the quadratic formula is telling you. If you've just been using it, because you know when you see these words, you use the quadratic formula and somehow it gives you the answer. You don't understand it well enough to function well on the test. Okay, you want to develop that understanding. You want to lock that in, hopefully in a position at this point after having worked the whole semester to do that, because most people aren't there yet. Some people are. Okay. So let's just take it serious. The quadratic formula tells us two things. It tells us the x values that make y 0. And it also tells us the axis of symmetry. That's what you need to understand about the quadratic formula, not a formula that you memorize and use without understanding what it's telling you. Okay. But the formula that you use in a situation like this, it tells you critical things that you need to know about the graph. Well, here it is. The axis of symmetry. Where do we see the axis of symmetry in here? Well, I circled it. I've done that numerous times in this course and in the okay. I said it. Okay. This expression tells you when y is equal to 0. And I wrote y when x equals 0. Carelessly. So if you're really in the E class nation, understand what I did. One of my long series of low dividends. Careless errors. Okay, so there we have it. The axis of symmetry is that x equals negative b over 2a. Just ignore the plus and minus. There's your axis of symmetry. I've explained why. axis of symmetry is halfway between your zeros, because that's what symmetry means. And halfway between negative b plus and negative b minus, this thing is negative b. Divided by 2a, you have your axis of symmetry. So we have this. And I mentioned the important idea that the axis of symmetry is halfway between the zero. Okay, well, now our conclusion is that y equals negative b over 2a, which comes out, you know how to identify a, b, and c. Everybody okay with that? You identify a, b, and c, use a and b, and plug it in, find your axis of symmetry is x equals 6. Okay, I mean, I wrote x equals 6 here because I have a picture. Okay, well, the thing you do now is, you know, it's not a matter of memorizing. First you do this, then you do this, then you do this. It needs to be a matter of you visualize, and even if you're not asked for a graph, although here you are, you represent everything you can on the graph because that sticks with you much better for most people than memorizing 50 formulas. Okay. A few pictures replaces numerous formulas. You want the formulas too, but you don't want to have to memorize too many of them. Okay. Anyhow, there's your axis of symmetry. What's that mean on the graph? It means we draw the vertical line where x equals 6. And that's the axis of symmetry. So it means it's a parabola that's a reflection on this side. It's a reflection of what it is on this side. And hopefully you have that picture and understand it. Okay. Well, once we have the axis of symmetry, we easily find the vertex. It's on the axis of symmetry. So to get the y coordinate, we know the x coordinate, it's actually 6. To get the y coordinate, how far up or down on the axis of symmetry is it? We plug in x equals 6. We just plug it in to that expression, and we get the y coordinate. Well, if we plug it in, this is what we get. You can check it out. You have the 6 here, x is here, and 6 is here. Okay, you do the arithmetic, and if I did it right, you get y equals negative 6. And that should be y. I'm like, here. Okay. Well, we put that on the graph. Here's y equals negative 6. Along this dotted line, they intersect at this point, which is the vertex. I can be believing that this is our vertex. Now, I got a little bit of a problem because the next thing we do, the last thing we do is we plug everything into the quadratic formula. We get critical ideas of the graph before we ever do that. And then the quadratic formula gives us a little more information. We get the vertex, then we want to get the y-intercept. If we have the vertex and the y-intercept, we can already draw a pretty good graph. We know the shape of the parabola. Okay. We get the y-intercept. Well, the y-intercept occurs when x equals 0. Again, the idea. Y-intercept when x equals 0, x-intercept and y equals 0. Those aren't words to memorize. Those are ideas to understand deeply. We use them again and again. Almost anything in graph, we've got to use the definition of the y-intercept and the x-intercept. So, you know, on the y-axis, x is always 0. So the y-intercept occurs when x equals 0. On the x-axis, y is 0. So the x-intercept or intercepts will occur when y equals 0. It's that simple, but you really have to understand it. Rather than, as I've heard many people do, just sit at home and imitate what you saw on open math videos and be satisfied that you got the right answer. It's not enough. Okay. Again, take that as a good piece of advice. Okay. Well, if you let x equal 0, you're gonna get y equals 30. That's very, very good. Everything with an x in it. In this case, it's nothing, it's 0. So you got y equals 30, so that your y-intercept is 0, 30. There it is. Okay. Now we got 0, 30. And I didn't do it over here because 30 would have been way up in here. Have to redraw the graph. Yeah, you gotta do that sometimes. Don't leave yourself enough room in the paper because you correctly anticipate what's going to happen. Or you didn't think that was the paper. Okay, well, anyway. 0, 30 here. And if this is 30, then -5 or -6 would probably be down here. And there's your vertex. Okay. Now, I drew a parabola at this point with this vertex. That's enough information to draw a pretty good approximation to the parabola. And I see that I have two intercepts here. Now, I calculated the intercepts to get these numbers, but before I ever calculated it, I estimated. I said, well, it looks like this point might be between 2 and 3 units to the left of the axis of symmetry, and this point 2 or 3 units to the right. You know how to look at a graph, you know how to scale a graph and make estimates, and I think it's important to be able to do that. Very much enhances what you're doing with the algebra. So, okay, maybe 2 or 3 units to the left, two or 3 units to the right. Turns out I pretty well nailed it, but that's the second thing I nailed today. I probably won't nail anything else for another year. Okay. So x-intercepts occur when y equals 0. Y equals 0 when x equals -b plus or minus b squared minus 2a equal to 2. Okay. That's like 2 and 4. Anyhow, if you do that and plug the a, b, and c in, this is what you're going to get. Okay. Now it's going to be 6 plus or minus the square root of 24 over 2. I went ahead and approximated the square root of 24 is 4.9. It's fairly close. Okay. Then I divide 4.9 by 2, got 2.45. Gave me 8.45 or 3.55. Notice it's 6 plus 2.45 is 2.5 units to the right of 6. So I said this should be 2 or 3 units to the right of 6. It's right almost halfway between 2 and 3. I was just lucky that it came out that close. Just by looking at the graph. And 6 minus 2.45, well, that's 3.55, and that's almost 2.5 units to the left of the vertex. You want to see that, you want to understand that. And you want to think about that. Because if you do, and if you've got a mistake someplace, it's going to show up. And you're going to have to correct it. Okay? Get more points. You better in the course. You're going to think a little better. Okay? Feel good about yourself. All that stuff. Okay. Well, there it is. There's the graph, and that's the process that we use to graph the quadratic. Now, there's an alternative process. You want to use completing the square, put it in vertex form, and use transformations. That's great. Okay. That's even better in some ways. You should be able to do it all. Okay. Now I commented, didn't have time to work it out, but we're going to do it here. That the vertex form of this then is x minus 6 quantity squared minus 6. Now, why is that? Well, if you understand transformation, you see that this takes the x squared graph, shifts it 6 units to the right and 6 units down. Okay. So this is a shift. Well, where's the vertex of the y equals x squared graph? It's at the origin, right? Okay, the vertex starts here. Then we shift 6 units to the right and 6 units down, and lo and behold, we're at 6, -6, and that's where the vertex is. Okay. So It's that straightforward. And the fact that there's no number in front of x squared means we don't have a vertical shift, a vertical stretch. At a vertical stretch, we have to do that before we do the shifts. Okay. Now that brings up a whole topic of transformations. We did extensive work on that. You're probably going to need to review it because I said everything that can be said numerous times. Some people pick it up, some people don't. Okay. Go back to the video, refresh it, lock it in. Simple one. Goodbye. Peace and love. Lock in. We might talk about it next time. The question comes up. Okay. So I ask everybody to write down the zeros of this function. So everybody wrote down, I think. Everybody wrote down 4, -7. I didn't look that closely at the signs. I know you were looking at the right thing, but there we have it, okay? X squared plus 8 can't be 0. A couple of people wrote down 8 or -8 or something, okay? And if you think about it, you plug -8 in for x squared, you're going to, for x and square, you're going to get 64. 64 plus 8 sure ain't 0. Okay. In fact, x squared plus 8 can never be 0 because x can't be negative. Okay. And when you add the 8 to something that can't be negative, it sure isn't going to be 0. It's going to be at least 8. So I want to be a little careful about that. Okay. So we can already start. With the graph. And it's sufficient if we just eyeball, if it's all -7 figures, we'll put it out there about this far little ways. And then y happens. And then if 7's out here, if that's 7, then maybe this is 4. Maybe that's more like 3.5, but close enough. Okay, you don't have to spend 15 minutes lining off the graph and units of 0.1. No one knows to do that. You don't have to overlabel the graph. If you can understand how big 7 is compared to 4. 4 is a little more than half of 7. Okay. 7 is this big, 4 is probably this big. Close enough. Now, if you think 7's this big and 4 is this big, you've got a problem and you want to correct that. Okay. Because 4 is certainly not bigger than 7. All right. Okay, okay, so we've got the zeros. What is the next thing we want to get? Okay, so they told me find the y-intercept. Okay, again, zeros and y-intercept are really easy if the function is already factored. Okay. If it's not factored, then that gets to be an issue. But I'm not stressing that completely. Okay. Y-intercept. Well, if that's a 0, this is going to give you -4, this is going to give you 7, and this is going to give you 8, right? And 4 times 7 times 8 is 4 times 56, which is 224. And so now it's hopeless to use equal scales on the y-axis and the x-axis. We're going to put 224 at a convenient point. Okay, that's going to be 0, negative 224. Fair enough? Okay, well now, how are we going to connect those points? Yeah. Now we got to go through negative 7, 0. We've got to go through 0, 4. We've got to go through, and that's 4, 0, not 0, 4. Do that half the time. Right. Well, we can make a guess. We think maybe the graph can't start down here, go through here, and come back and get this because it can't go through the x-axis except at this point and this point. Why? Because any number other than 4, negative 7 isn't going to give you 0 for any of these. When you multiply 3 numbers that aren't 0, you're not going to get 0. Okay, the only way you can get 0 is if one of those 3 numbers is 0. And that only happens when x is 4 or x is negative 7. So we can't go through the x-axis anyplace else. Well, that kind of changed the plan. Looks like I thought we were going to have to go in here and come up here someplace. Okay. That's pretty much what the graph looks like. Now, there are subtleties in the graph, concavities and inflection points, and stuff that you learn about in calculus. You have something to look forward to. But we don't need them right now. We're just trying to get the overall shape of the graph. But there is one important thing we have to know how to do, which is look at the end behavior. So my conjecture here, the only way I can think of to go through these 3 points is this way. Okay. We do want to make sure. Okay, well, in this case, it looks like the function goes to infinity as x goes to negative infinity. As we go to the left, this thing gets very steep and goes up very high. And on the right, well, same thing. It looks like it goes to infinity as x goes to positive infinity. We want to check that. Okay. And there are certainly times when you really need to check out the end behavior before you sketch the graph. In this case, it wasn't really necessary, but we check it out anyway, just to make sure we didn't miss something. Okay, so we check out the end behavior. A large positive x implies the right x over time. Large positive x implies that this is large and positive, right? This is large and positive, and this is really large and positive. We're squaring that big number x. I'm saying that really implies a humongous positive y, because y is equal to this times this times this. So if we take three large positive numbers, one which is really big, and multiply them together, we get this humongous positive number. So as x goes to infinity, y goes to infinity, not negative infinity, to infinity. Okay. I'm just here trying to give myself a little more room. Well, if x is a large negative number, then so is x minus 4, and so is x plus 7. Now, x squared plus 8, if you're squaring that large negative number, you're going to get a really big positive number. That's going to be a large positive number. Okay. Well, then. That means if this is a large negative and this is a large negative, you multiply two large negatives, you get a huge positive. And you're going to multiply that by another huge positive, which is going to give you a humongous positive number again. As x goes to negative infinity, y goes to positive. Okay. And that's what we see. And we denote that on the graph. Okay. This we're really kind of moving upward pretty soon. Now, there's much more to graphing these things, but that's a good start. And that's all. Okay, going a little further with this graph. I think we estimate let's say f of -2 and f of 3. Okay, so I'll give you a second if you haven't already. That's a beautiful graph. Looks just like mine. It's great. Okay. If you haven't sketched the graph, just slop one down, make sure you label the 3 points on the axis, and then see if you can construct an estimate of f of what I say -2 and f of 3. Okay, so again, what I've asked is we, based on your copy of this graph, estimate f of -2 and f of 3. If -7 is here, -2 probably about here. Here's the line x equals -2. Here's the point on the graph where x equals -2. And here is f of -2. Now, I didn't have that. And this labeling is kind of in the way of what I'm going to label now, that's inevitable. I don't forget what I labeled. If my arithmetic is correct, this point is 0, negative 224. Now, on my graph, what would the y coordinate be here? Just write down a number on your paper and circle it. Okay, so I'm getting like negative 240, negative 250. Okay. I think it's lower than that, but those aren't great estimates. At least they're in the right ballpark, okay? At least they're not above this point because it went below, right? So you went below it. How to go further? Okay, if this is 224, then I could actually line this off. I wanted a really good estimate. 200 isn't too much higher than that, so that would be 100. It looks like maybe negative 300 or even a little more. Okay. So, you know, you can refine the estimate. I'm going to estimate. Negative 300. I go negative 320 or something like that. This is, yeah, it's about half again that. I go 332. Okay, but it's okay. You got an estimate, right? And the estimate's in the right ballpark. Okay, can you do a similar thing to estimate f of 3? Do that quickly. This is a review. We got to review quite a bit of stuff, so don't want to take a lot of time on it. Okay, to estimate f of 3, well, here's 4, where's 3? 3 is about here. So I can draw the line where x equals 3 and project over to the y-axis. And I can say that, okay, looks like maybe that's negative 100. And obviously that's not negative 80, but let's use nice round numbers. They're close enough. Okay. Okay, so estimate f of negative 2. You have to estimate y when x is negative 2. So we draw a dotted line here representing the line x equals negative 2. And that's about right. You know, if this is saying maybe that's about 2, maybe it's could be closer. And then to do f of 3, we do a dotted line here and see what the y value is. Find the y value on this line, we project over here and we say, okay, maybe about negative 300. And over here, say, okay, look, if this is 224, that's probably about 200. If this is 224, that's less than half of 224. I'd say it's about 80, but I'll just say, okay, negative 100. I accept that as an estimate. Not a great estimate, but it's a reasonable estimate. Okay, then. What's the flow? Now, this means an interval. It's not parentheses, it's not a point, it's an interval. Make sure you understand interval notation. Okay. So how do you estimate the slope? Well, the interval from negative 2 to 3 is here. So Right there's the interval -2, 3. The slope. Let's say the average slope. We didn't have that word average before. Well, you got the graph point here and the graph point here. You draw straight line segment. We can take our fundamental triangle. And we estimate the rise and the run. Okay, well, we've estimated the coordinates of these points. I've written that out kind of small, but we myself in that room, but hopefully it's legible. Yeah. On the interval from -2 to 3, we go from the point -2, -300 to the point 3, -100. We do the fundamental triangle. We see that the run would be 3 minus -2 equals 5. And we'll go from the left point to the right, meaning we'll follow the path this way. Remember how we did that. And the rise is -100 minus -300 equals 200. So that the slope is (200/5) equals 40. Also, you want to make note of the fact that the slope is the average rate of change. So slope is average rate of change. These are our safe rate of change. On the interval -2, 3. Now, this is a picture that we spent some time on back in January and early February. Okay. It's important for understanding essential aspects of the graph that are going to be really important when you take a calculus course. You understand this is a significant head start in understanding what's going on in a calculus course rather than just imitating it by a bunch of simple formulas. Okay. Meaning you want to make a good grade in calculus, can be real helpful. You get by, depending on the calculus course you take. You're not going to get by the engineering calculus just by imitation, at least not with a good grade. In applied calculus, somewhat easier course. Okay, with a little different focus. Okay, this should be straightforward, but if x is -2, y equals 2 to the negative x would be 2. The negative of -2, which would be 2 squared, which would be 4. So if you write this out, and people are doing a good job in general of writing out the calculation. You really want to do that. Okay, then you get. Well, you're gonna get 2 here, you're gonna get 1 here. When x equals 1, you get 2 is a negative 1. When x is 2, you get 2 is a negative 2. 2 to the negative 1 is 1 over 2 to the 1, which is 1/2. 2 to the negative 2 is 1 over 2 squared, which is 1/4. And that's very basic pre-algebra level arithmetic, okay? Make sure you've got it down. Make sure you know what a negative exponent is and what it does. If you made any mistakes on the negative exponents, and some people do, if you made any mistakes with negative exponents, let this be the last time you do this. Okay? Really lock it in. Have to know the negative exponent. And you should know why. I don't have time to explain why again, but at least know that it's so. All right, well then, it becomes very easy to graph this. We get it from here. And from here. And from here. Here. And from here. So you get the idea. And you don't want to let it hit the x-axis to talk away from it. It's no excuse. Center of the chalk line never actually goes to the x-axis. It should have been going through this part. All right, so there it is. Now there's one of the problems you see on the practice test is make a table and graph y equals 6 to the x. Okay. Well, you get bigger numbers. It'll be as big as 36 and as little as 1 over 36. But you just follow the process and you get it. The one thing I want to emphasize in closing is the importance of doing the graph. Okay. The very first problem with the linear function, we had to interpret f of 2 equals -4 as a point on the graph, right? A whole lot of what you do here needs to be, if at all possible, represented on a graph, because that's the way it'll really sink in. You can imitate the algebra when cows come home and not have it sink in well enough to do well on an exam. Okay, and to go on into more advanced courses that rely on this course. You're going to see if you're in a curriculum where you got to do pre-calculus 2, it's a harder course. You want to nail this course. If you do, learn to think better mathematically, okay? And a lot of you, it's applied calculus, which is a little easier than pre-calculus 2. Engineering calculus is much harder than anything you've ever thought. Okay, it's a very hard course. Most of you are not in the track. It leads to that course, okay? Doesn't mean some of you might not be, so we're going to prepare you for that too. Okay, well, bottom line. Get the picture. And usually the pictures are bad. Okay. I have to focus on that as much as I can. Got to memorize formulas, go ahead. But people memorize all kinds of formulas and then use the wrong ones because they don't understand what they're doing, because they don't picture it or whatever thing. Okay. Good luck. See you next time.